Hello ESM mathematicians, and welcome to the third and final lesson of the week. So if you can put today's title, which is Developing Geometric Reasoning, and the date, and in your exercise book you're going to fill in the number of sides and the name of the polygon. Polygon meaning many angles. So it's a shape we're looking for with a number of sides of 3, 4, 5, all the way down to 10. See how many you know the name of. Don't worry if you're not too sure, we'll fill in the rest a little bit later on. Okay, so first view, hopefully we're relatively comfortable with the fact that we're going to be calling that a triangle, quadrilateral, pentagon, and then notice how the word gon will appear as we go through. That's going to be a theme of what we're going to look at a little bit later on, and to break down those words to say what they mean. So today we're going to understand key terms such as polygon, regular, irregular, interior angles and some exterior angles, and know how to find and use the angle sum of polygons, and then we'll have a look into interior and exterior angles of them. So this thing we need to look at now is the sum of the interior angles of a pentagon. Okay, so we've got our pentagon drawn there, and notice how I have created 3 triangles out of it. And from previous lessons we know the angles in a triangle are to be 180 degrees. So the sum of the interior angles of this pentagon is 3 times 180, which is 540 degrees, a pentagon being a 5-sided shape. So I'd like you now to sketch each of the polygons below, and then splitting it into triangles using this same technique here, where you're going to do it from one vertices. Remember, a vertex is a corner, so your lines to create the triangles must come from one corner. Okay, we're not going to have any overlap in the triangles, just start them all from one corner. So you're going to draw me a hexagon and an octagon, and then you're going to see, by splitting it into triangles, the sum of the interior angles. So a polygon is a 2-dimensional shape that has straight edges. There will be no curves involved. And so the examples include the ones that we mentioned for the do now task. And polygon comes from some old Greek, which you'll get a lot of the shapes from. Poly meaning many, and gon meaning angle. Okay, so a polygon is many-sided, so that covers all of the hexagons, octagons, and all those. And if we go back to the original one there, notice how you've got penta meaning 5, hex 6, hepta 7. So it's 7 angles, octagon 8 angles, nonagon 9 angles are in there. Okay, so I'd like you to draw those 2 shapes and then see if you can work out the sum. So that's adding all of them together, the interior angles. Okay, so there's our hexagon, there's our octagon. And hopefully you've drawn the triangles to work out the sum of the interior angles, but we're going to look on the next slide to produce one big table. So I'd like you to get this copied into your book for me, please. The name of the polygon, the number of sides, then you're going to work out how many triangles are inside, and that will tell you the sum of the interior angles. So first of all, if you draw a triangle, you know you can only create one triangle inside, and that will be 180 degrees because the triangle's already there. Quadrilateral, 2, 360. See if you can follow the pattern and notice anything there as well as you fill in the remainder. So pause the video and have a go at that for me. Okay, so going through, you'll notice we're going 1, 2, 3, 4, 5, 6. The number of triangles increases by 1 each time, so that means the sum of the interior angles will go up by 180. Notice the pattern between the number of sides and the number of triangles. The number of triangles that can be created is always 2 less than the number of sides. So for example, on a 9-sided shape, our nonagon, we should be able to create 7 triangles. So we do 7 times 180. If we had a 54-sided shape, take 2 away, we'll be able to create 52 triangles. So the sum of the interior angles will be 52 times 180. So we need to use this information now to work out a little bit more in terms of the interior angles. So what I'd like you to do, I'm going to have, I think, 3 slides in a row here where a shape appears. You're going to draw the angle. You're going to annotate all the interior angles. Then you're going to show the exterior angles, and you're going to add up the interior and the exterior and see if you can notice a pattern emerging. Okay, so interior angles, those are our ones that go on the inside. And on this equilateral triangle, we've got 180 degrees. So the exterior angles, the one on the outside here, extend those, they must always be 120. Angles on a straight line add up to 180 degrees. Now, some of the interior angles, 180, some of the exterior, 120 plus 120 plus 120 is 360. Next shape, try for the same here. Okay, and these are regular pentagons, meaning they've all got the same side lengths, they're equal side lengths. Now, if we were going to annotate that correctly, we would draw a line on each of those lines to indicate their equal sides, but we'll come to that a little bit later again as well. So, interior, all of them will be the same, 108 degrees. The exterior, again, interior plus exterior must equal 180 because they're on a straight line. They're all up to 72. 5 lots of 72 there makes 360 degrees. So the exterior on that one also equals 360. So without even starting on this one, what do you think the exterior angles would add up to on this shape? Then fill them all in and make sure to see if you are correct. So there we go, interior and exterior on this one. And once again, there are 6 angles this time, but 6 times 60 is 360. The sum of the exterior angles will be 360 degrees, and this will be true for our polygons. So we need to write this information down with a big box around it. The exterior angles of a polygon will always add up to be 360 degrees, and each exterior angle must be 360 divided by n, where n is the number of sides. So for a 10-sided shape, each exterior angle will be 360 divided by 10, 36 degrees. Okay, so there is our original polygon, and there we've annotated on our exterior angle. And just watch as the shape gets smaller. You can see that's where the 360 degrees comes from there. Okay. So let's put a little bit of this into practice. I would like you now to calculate the unknown angle in each of these polygons. So work out what the total sum of the interior angles must be, and then work out then what is the missing one. Okay, so first one we've got is a 5-sided shape, so that's a pentagon. We've got 4 of the angles given to us. 5-sided means we can make 3 triangles, so the sum of the interior will be 540. Take all those away that we've got there from 540 to leave with A is 100, and then follow that same method through the rest. You've got A is 100, B is 150, and then the final one, C, 285 degrees. Okay, there are 4 more, so once again, pause the video and have a go at those 4. Okay, note how on some of these they're now asking for the exterior angles. Okay, so we know on A, for example, exterior angles must equal 360. We've got 2 right angles, that's 2 times 90 is 180, plus the 100 is 280. Take that away from 360, leaves A is 80. Okay, so in all of those top 3 there, the exterior angles must equal 360 degrees. And then in the bottom one, we've got once again a 5-sided shape, a pentagon. They must add up to be 540 degrees. 2 right angles is 180. So that leaves 360 on those remaining 3 angles. They're all annotated as x, so they must be the same. 360 divided by 3 is 120 degrees. Okay, now these are some very challenging ones, especially on number 5. So you'll need to spend a good 5 or 6 minutes on this, so do pause the video and see how well you can work through these. Okay, first up then, 4 interior angles of a quadrilateral are given to us there with various algebra, and it looks a little bit ugly and complicated there. First of all, we should know it's a quadrilateral, so the interior angles must equal 360 degrees. So those 4 that are given to us must equal 360 degrees. Then, if we collect all of our like terms, we can begin to simplify it, and we end up that x is worth 20, and then to the size of each one then would be 3 times 20 plus 80 gets the first one, 5 times 20 plus 10 is the next one, and so on. Substituting x equals 20 into all those four, you'll get 140, 110, 40, 70, double check, all those four added together is 360 degrees, so you know you are right. On the next ones, now you're not given a lot of information, but there is more than enough in there to solve the entire thing. So we've got the angles as, so for A, you know that those two angles on a straight line must add to be 180, and then same for B. Okay, and then we've got on the next one, answers appearing for E, F, G, and H. We can do a little bit more work on angles to actually make those last two a little bit easier to solve as well with some new facts. So, challenge question. The exterior angle in a regular polygon, so that means they're all going to be the same, they're all going to be 15 degrees. How many sides does the polygon have? How would you work that out? One very simple, quick calculation would be able to solve that. Okay, so for this one, as we said earlier, the exterior angles must always add up to be 360. If we know they're all the same, because it's a regular polygon, and each one is 15, we can simply do 360 divided by 15, and that gives us 24-sided shape. Okay, next little bit here we'll look at is some parallel lines, looking at alternate, corresponding and co-interior angles, and get some definitions for these. So that's the sort of thing we're going to be looking at being able to solve by the end of the lesson. I can tell you from that diagram, even though we've only been given one angle, you will be able to solve the other 5 by the end of this lesson. Okay, that's all the information we would need to be able to solve those 5 angles. So, this is what you'll need to copy down exactly as it appears into your book. So, these parallel lines with a line through them, and these are what we're going to look at. There are corresponding angles, and those are the 2 highlighted there. Those angles are equal. Make sure you've got the arrows on the lines, because that shows they are parallel. If they're not parallel, you cannot use these reasonings here. Alternate angles, note how that forms more of like a Z shape. They are equal. And then allied angles, or sometimes referred to as co-interior, add up to 180 degrees. Angles that add up to be 180 are supplementary. They supplement each other to make 180 degrees. Okay, and again, these all must be parallel lines. So here's a few more examples of each of these. So here are some alternate angles, and note how these appear slightly to be Z-shaped. So those are the same. Likewise again, we've got our Z shape, those are the same. And note how you've always got to show with the arrows that these are parallel. So it doesn't matter which way it's showing, that's still a Z shape. And we've got a few more examples here. So if you just want to take your time to look over those, and that's clearly then on those bottom ones, you can see where that sort of Z shape appears. Okay. The others we had are corresponding angles, and these look more like the letter F. So that's a backwards F there, and these will always be the same. And then the final one we'll look at is the co-interior, I say the one that's also referred to as allied angles. These are more of a C shape. And these are ones that add together to be 180 degrees. And these again require those parallel lines to be indicated. So let's use some of this information as an example. So let's get this one down into our books as well, please. State the size of each lettered angle in the diagram and give a reason. So once again, we've got 4 angles, but only one has been given to us. But we can use that information to solve them all. They're labelled A, B, C. You do not have to go in that order. Okay, so we could say angle A is 62 degrees because that is an alternate angle to 62. You can see how that creates a Z shape. B allied angle, so that's our co-interior, those two together must add up to be 180 degrees. Angle C is vertically opposite the 62 that's given to us, or you could use the third rule we learnt earlier, and that's corresponding angle to A, so those two must be the same. Okay. Or you could have had a look at the one next to 62 to the left of it. Those two would have to be 180 degrees, so that one above C must be 118 as well. Or you could use its alternate angle to B, and then take that away from 180 would give you C as well. There's loads of different ways, but that would probably be the simplest one that's appeared on the screen there. Okay, so what I would like you to do is there is a diagram on the screen. I would like you to fill in the blanks there, angles H and which other angle are corresponding angles, and fill those in to get those 6 statements as true for me, please. Okay, so these would be the answers we should get here to fill them in. Angles H and D, then D and F, E and D, B and F, C and F, and then final one, C and E are alternate angles. Okay, there are 12 questions on the screen there. You're going to need to solve all of the letters there. Be careful as we get through, as some of them require you to answer a few more. So there are in fact 26 angles in total to find for me. And if you're struggling on some, by all means play ahead on the video, but do pause it so you can have a go at as many as you can independently. Okay, so answers will be appearing now for those who've done the first few, and then just pause as you need to answer the rest. Okay, so I've tried to highlight as well how you may have found the rules on each of these to solve them. Okay, so we're using our various things, our vertically opposite, allied, alternate, okay, so all our answers should be on the screen for you now to double check for. Okay, now there's one big definition where we're going to have a look at, and this is the word, lovely word, transversal. From the Latin transversus, lying across. So that's now Latin and Greek we have covered today, and a lot of the mathematical terminology will have Latin or Greek sort of origins within it. Okay, so the correct definition of transversal is a line that crosses at least 2 other lines. Okay, so on the bottom there are 3 examples of transversal. Now, they do not have to cut through 2 parallel lines. That's often a misconception, and it is only transversal if it cuts through 2 parallel lines. It just has to be at least 2 other lines. Those lines do not have to be parallel. Remember, parallel lines are 2 lines that are always equidistant. They're always an equal distance apart, but sadly they will never ever meet. They say that same distance apart. So here are some examples and non-examples of transversal. We've highlighted the transversal line. The ones on the left, clearly they cut through at least two lines. The ones on the right, they're only cutting through 1 line, so they are not examples of transversal. So this brings together a lot of the terminology we've been seeing and a lot of the designs on the shapes. What does each of these things, that looks a very messy square there, but what are all the lines and arrows about? Okay, so hopefully we should get all the first one. The little boxes there are right angles. The 2 lines means to indicate that any that have those 2 lines on have equal side lengths, and the arrows indicate they are parallel. So the 2 lines that have only got 1 arrow, those 2 are parallel. The other pair of sides have got double arrow to show those are parallel. Okay, so they're not all parallel to each other, so that's why there's a different amount of arrows for each. But the equal side lengths, all 4 sides have got 2 lines because all 4 are equal. Okay. So, which of the following statements are true given that diagram there is AB is parallel to CD, and is CHE equal to FHD. Okay, so is AB parallel to CD? No, it is not. That is false. A couple of reasons. One, you'd expect to see it clearly annotated to show they were parallel if they were, and also angle BGH and DHE would have to be equal if they were parallel. Okay, they would be equal based on the rules we looked at earlier. Is angle CHE equal to FHD? No, it is not. So what we should be looking at here is angles on a straight line. So CHE, oh sorry, I'm looking on the wrong side here. Sorry, CHE is equal to FHD. Absolutely, that is correct. Because FHD, that will be 106 degrees, because that's angles on a straight line. 106 plus 74 is 180, so FHD is 106. CHE would be then vertically opposite, so that also would be 106 degrees, and you could prove again you've got a straight line underneath, so 106 plus 74 would form the other straight line of angles that out to be 180 degrees. So first one is false, second one is true. Okay, Sam has said that he could determine the measure of every angle in the figures A and B without actually measuring the angles if he knew just one of the angles. Doesn't matter which one, but if they told one angle, could solve everything in each of the figures. Is Sam correct? I think for figure A, because they are clearly annotated as being parallel lines, we can bring in our rules that we learnt earlier with all of our corresponding, allied and alternate angles to be able to solve them if we are given just one angle. But for B, they're not parallel lines, so if we knew one angle, we might be able to solve a couple, but we're not going to be able to get all 8 angles correct. So back to the first question here that we looked at, and I promised after learning that, you will be able to solve every single angle on that sheet for me. So, given that 152, work your way through and figure out the rest of those angles for me then, please. Okay, so UYZ should be 152 degrees. That would make WYV 152, because then they'd be vertically opposite. SZX 152, vertically opposite there. VYZ would be 28, because then they're the co-interior, the allied angles that must add up to be 180 degrees. And then XZT would also be 28. There, you could either go angles on a straight line to make 180 degrees there. 152 plus 28 would make the 180 degrees. Okay, so that would be what we're going to cover for the lesson. There is one final question to really push some people who want to look at it here. Find as many pairs of angles that are the same, and find as many pairs of angles that sum to 180 degrees. Okay, so that does conclude the third and final lesson that we're going to look at on angles. If you can double check on the work submission and on your Hegarty maths to make sure you've done the assignments that are tasked and set for you. And in the meantime, any questions, direct them towards your teacher. Hope you've completed all and enjoyed this week's work, and I'll catch up again with you next week. In the meantime, take care then, Year 7.